Hi, my name is Ethan Nowoski, and this is the Week 4 explainer video for Chapter 16, Question 81. The question asks, one way to monitor global warming is to measure the average temperature of the ocean. Researchers are doing this by measuring the time it takes sound pulses to travel underwater over large distances. At a depth of 1,000 meters, where ocean temperatures hold steady near 4 degrees Celsius, the average sound speed is 1,480 meters per second. It's known from lab measurements that the sound speed increases 4.0 meters per second per 1 degree Celsius increase in temperature. In one experiment where sounds generated near California are detected in the South Pacific, the sound wave travels 8,000 kilometers. If the smallest time change that can be reliably detected is 1.0 seconds, what is the smallest change in the average temperature that can be measured? So, from this problem, we're given a few things. We have our P1, which is near California, and our P2 somewhere in the South Pacific, and that's 8,000 kilometers. So we have our given, which is 8,000 kilometers, which can be translated into 8 times 10 to the 6th meters. And then we have our velocity for sound through water, which is V1, and that is 1,480 meters per second. And then they give us this conversion, which is the change of velocity over the change of time, or not time, change of temperature. Be very careful with your T's. And that's 4 meters per second over 1 degree Celsius. So per 1 degree Celsius that changes, it will increase the velocity, the sound velocity by 4 meters per second. And then we have the change in time that they gave us. The small difference is 1.0 seconds. And they're asking us to find this change in temperature, big T right here. So first things first, we have our V. We're going to start with our equation for velocity, which is V is equal to distance over time. We're going to augment this to time is equal to distance over velocity. And then we're going to solve actually for how long it takes for the initial sound pulse to travel that 8,000 kilometers. And so what we do is we have our, we plug in our values, and we solve that the time is 5,405.41 seconds. That is the distance that it should take to travel that 8,000 kilometers. However, we need to plug in that 1.0 seconds as the change in time as kind of an error, and so we actually have to subtract that from our t. We have to do t minus that change in t to get our our actual time that it takes, which is 5,404.41 seconds. So that's the time that we're going to be using now. And so what we do is we plug that back into our time is equal to distance over velocity equation with a new v now, because we're solving for a new velocity, because that's what's going to help us find our change in v and then our change in temperature. And so we have our new value for time, which is 5,404.41 seconds, and we have our distance, which stays the same. And so then we solve for v2 as 1,480.27 meters per second. So with that value, we can solve for the change in velocity, which is v2 minus v1, as we all know, and we can get that the change in velocity is 0.27 meters per second. And so now we have to use our conversion that they gave us in the equation, which is 4 meters per second per 1 degree Celsius, and we can track this to do 0.27 meters per second over 1 times 1 degree Celsius over 4 meters per second, which is essentially just dividing the 0.27 divided by 4. And we'll get 0.068 degrees Celsius change. So the temperature of the water in the ocean will increase by 0.068 degrees Celsius. So that's our final answer right here. Thank you.